Hello guys, next we see how to implement LRU Cache. If you haven't seen on how do we design LRU Cache, please go ahead and see my video. There we discussed how do we design a customized double linked list to serve operations of insertion, deletion, search and size in big O of 1 so that we can make our put operation of LRU cache and get operation of LRU cache in big O of 1. So this is the source code, I mean pseudocode for the put operation. Let's say that we want to put k. We will check initially. We search whether in a double linked list whether k is present or not. If it is not, if it is present, then what do? We delete that from that position and again we insert k. Correct. If it is not present, what do? We check whether we reach the maximum capacity. If we reach the maximum capacity, we go ahead and delete the head of the double linked list. Head of the double linked list from the DLL. Next, we'll go and insert the new node. We'll go and insert the new node. Now let's see how can we execute. I mean, how it works using the simple example. Let's say that these are the elements we are getting in a cache. So initial double linked list, we have head and tail as a null, and we have a count, that is number of nodes in as a 0, and the map key value place we don't have anything. Let's say that capacity of the cache is given is 3. Let's say the capacity of cache given is 3. Let's say that we receive first element 7. We receive first element 7. That means that we try to put 7. So what are we doing? We are searching for k. So we don't have any elements. So we don't have any elements in the cache. What do? So we'll check the capacity. Capacity is initially 0 because count is 0. So we check that. We'll go ahead and insert k here. That means that we will insert 7 here with head and tail point into the same position. Let's say this address has a 10. So that means 7 and it address is 10. Okay. Next we'll insert 0. So we'll call put on 0. So again we'll check whether my DLL contains 0. No, right? Because we only have 7. Then we'll check whether we reach maximum capacity. No, sorry, we supposed to increase the count to 1. No, because our capacity is 1. Our count is 1. So however we have capacity up to 3. No. So what do? We just have to go ahead and insert. So because this is a tile insertion, what do? We increment tile, we insert new element here 0. Let's say its address is 20, and we update as new, update our tile. Okay. Then we insert in a map that is 0 and address is 20, and we increment the count to 2. Increment the count to 2. Let's say that now 0 is done. Let's call put on 1. Put on 1. Again we check whether our DLL contains 1. No. So what do? Is our size reach our capacity, maximum capacity? No. Then we'll go ahead and insert 1. To do insert 1, what do? We will put 1 here. Let's say that its address is 30, and then we update our tail to the last node, and we'll put that in a this entry in a map 130, and our count incremented by 1. Our count is incremented by 1. So now it's done. Now let's call put with a 2. Again we search for the elements with the 2. Do we have 2 here? No. Then what do? Then we size reach the maximum capacity. Yes. Excuse me. So then what do? So we delete the head key. So we delete the increase there here head. So our head is updated to here. Then we'll go ahead and insert k. That means we insert 2 here. So let's say that its position is its address is 40, and we update our tail, and whenever we delete here, we remove from here also, and we'll put new entry 2 and 40. 2 and 40. Correct. Now 2 is done. We don't need to update the count because it's still our capacity is 3. Correct. Now let's say that we receive 0. Let's call put on 0. So then we search for the 0 and DLL. Do we have 0 and DLL? Yes. So then we'll get the when you do a search in the map returns 20 for us. Then what do we have to do? We'll have to go call delete on this 0. So we will delete 0 from here, and so whenever you delete here, our head is updated to the next node, and again we will insert 0 in the end. So 0, it's inserted with a new address 50 and our update tail, and respective our insertion here also this address also map is also updated to 50. Okay, so we don't need to update the count because size is still 0, 3. So 0 is done. Now let's call 3. Let's call put on 3. So we'll again search for the whether 3 is present or not. We don't. So we check whether it's the capacity is reached. Yes. Then what do? We delete the first entry. That is, we delete the first entry and we update the head to the new position, and then we insert 3 here. Insert 3 here, and let's say its address is 60, and then we update the tail, and then we insert the 3 entry here with a 60. And I'm sorry, whenever we delete entry, we delete that entry from here also. What was it? 2031. One is deleted. So probably you can understand the rest of it, how it's working. Next we see how the get works. So get operation is relatively much easier than put. So here when we call get on k, we are searching for that k firstly in the double linked list. If it is present, then we do delete from that position and we do a tail insertion, isn't it? We did delete and we call insert from our customized double linked list. If it is not present, we just return false. Which is not present, we just return false. Let's see one example, a couple of examples, small example how it works. Let's say that currently the cache looks like this with the cache capacity as a 4, and we have the elements 2035 and their respective addresses. Head is here and tail is here, and the current value of a map is 2 and their values, and that has references. Let's call get on 1. Get on 1. Initially what is doing, it's searching for 1 in the double linked list. Do we have 1 here? Do you have 1 here in the map? No. So it doesn't do anything, just returns from there. Next, let's call get on 0. So what happens when we get on 0? Again, it searches for the 0 in the map. Yes, 0 is present. Then what do? It is calling DLL delete. So in the double linked list, we are doing delete operation. That means that it is deleting from both from the double linked list and also from the map. Then what it's doing is it's doing the tail insertions. So it is inserting 0 here with a new address as a 50 and updating tail. So tail is pointing to 0 now, and it also makes a new entry in a map with its address. Correct. Now 0 being the least recently used, 2 being the oldest. So this is how get works. The last one is printing the cache. This is the easiest. So whenever you want to print cache, what are we doing? We are calling DLL print in reverse. So we just printing the double linked list in the reverse order, starting from tail to head. So what does it print in this example? We have a cache looks like this 2013. It prints 3102. 3102. So this is how the LRU cache is implemented of 3 operations: put, get, and print. Put and get are implemented in big O often, but print because it has to iterate through all elements of the cache, so it's in big O of n, where n is the capacity of the cache. N is the capacity of the cache. The one of the applications of the cache you can see online is IMDb. If you ever browse IMDb, when you go to the footer, close to the footer of that IMDb, you can see the recently visited pages. You can get a clear example of how LRU cache works there. Yeah, thank you guys, and you can find the source code for this program in the comment section of my GitHub link. This is only the pseudo code, whatever we discussed here. Please feel free to reach me for any queries. Thank you.